Unit 5, Part 3, I can multiply polynomials. First, we're going to talk about area model multiplication, which we're going to bring it back a little bit to then advance it and use this concept to then multiply these more advanced polynomials. So area model multiplication just means we're going to use a grid to multiply. So if we have 3 times 4, 3 times 4 means we go 3 across and 4 down. And if we fill in that rectangle that is created by 3 across and 4 down, we can discover the area, or what 3 times 4 is. So we would count up how many squares would be shaded, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why 3 times 4 is 12. And then we can also do the same thing for something larger, 7 times 8. So we can go 7 up, 1, 2, 3, 4, 5, 6, 7. And 8 across, 1, 2, 3, 4, 5, 6, 7, 8. And then create that rectangle. And then we can count up how many squares are in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We could continue on, but there'd be 56 squares. And so, while area model multiplication helps us understand multiplication, it's not a very good tool for long, big numbers because counting up all these squares gets to be a little bit tedious. But I wanted to make sure you understood this application of area model as we are going to be using it for polynomials. So since area model isn't great for larger numbers, a way that we can utilize the area model is by breaking larger numbers down into smaller numbers that we understand. So if I do 6 and 14, I can use 6. 6 is good. But 14 I'm going to break up into 10 and 4 because 10 is a really easy number to multiply by. So I can do 6 times 10, which is 60, and then 6 times 4, which is 24, and then I can just add those two pieces together to get what 6 times 14 would be. So 60 plus 24 is 84. And if we want, we can check with our calculator. 6 times 14 is 84. So that's an easy way to break up our multiplication and then make it more something we can do in our head. So if we try this with another example, we can do 3 times 26. So I could break this up into 20 times 6, or 20 plus 6, excuse me, 20 and 6. 3 times 20 would be 60, and then 3 times 6 would be 18. Which then added together would be 78. So now we're going to take this concept and we're going to apply this to our polynomials. So when we multiply polynomials, we're going to take the number outside the parenthesis, 4x, that's our monomial, our single term polynomial. And then we're going to take what's inside the parentheses and break it up. So we have 5x minus 3. And then we're going to multiply this single piece over here by both numbers. We're really applying that distributive property. So we're doing 4x times 5x. 4 times 5 is 20. X times x is x squared. Please make note of that, that x times x is going to be x squared. And if we're struggling to wrap our mind around that, if we just change x to a number, we think about x as being 5. 5 times 5 is equal to 25. Or we can simplify 5 times 5 as 5 squared, which is also 25. So if you multiply anything by itself, you get that number squared. And since we don't know what x is, we can't figure out an answer for it. We don't know that it's 25 because we don't know if x is 5. So we need to use that simplification of any number times itself is going to be that value squared. Just like we can rewrite 4 times 4 as 4 squared. So we're going to use that concept with those variables. And then once we multiply that first box, we move to the second box. So now we're going to do 4x times negative 3. So numbers times numbers, we do 4 times negative 3, which is negative 12. There's only the one x value here, so we just bring the x along. There's nothing for x to be multiplied with. And then that's our answer. We just simplify it. We have 20x squared minus 12x. Since there are no like terms that can be combined, that just remains our answer. So let's try another example. We have negative 3x, which is going to be our number on the outside. And then we have our two values on the inside, 3x squared, and then positive x, or positive 1x. I'm going to put a 1 in front of that so we remember that there's that one value. All right, so we'll start with doing negative 3x times 3x squared. So first we'll do the numbers. We can do negative 3 times 3, which is negative 9. And then we need to do x times x squared. So we can think about this in a couple different ways. The way I like to think about it is x times x squared is 2x's. So we have x times x times x, which means I have a total of 3 x's. So that is going to be x to the third power. The other way to think about it is using our exponent rules. We have x, which when there's no power is really raised to the first power, times x to the second power. So we can do 1 plus 2 and get x to the third power. So whatever way is easiest for you to remember, but if we do x times x squared, we get x to the third power. And then we just put those pieces together and we get negative 9 times x to the third power. Now that we've completed the first box, we move to the second box. So we're going to do negative 3x times positive 1x. So we do negative 3 times positive 1, which is negative 3. And then we do x times x, which is x squared. We have 2 total x's, so x squared. So we put those pieces together and it becomes negative 3 times x squared. And then we put those two pieces together to become our final answer of negative 9x to the third power minus 3x to the second power. All right, we're going to try one more example here, and this is just going to be a little bit longer because we have 1, 2, 3 terms inside our parenthesis instead of the 2 that we have been using. So we're going to start by putting our 2x on the outside, and then 3x squared plus 5x minus 7. And then we're just going to multiply that 2x by all 3 of those values. So we're going to start with 2x times 3x squared. So we're going to do 2 times 3, which is 6. And we're going to do x times x squared. And remember that is x to the third power because we have 1x here plus 2x's there. Gives us 3x's. So that is 6x to the third power. Moving on to the second box, we're going to do 2x times 5x. So we've got 2 times 5, which is 10. And then x times x, which is x to the second power. So we have 10x squared. And then lastly, we're going to do 2x times negative 7. So we're going to do 2 times negative 7, which is negative 14. And then there's just an x. There's nothing to multiply x by, so it just stays. So we have the negative 14 and the x come together to make negative 14x. All right, now we put our three terms together, and it becomes 6x to the third power plus 10x to the second power minus 14x. I do add that plus sign here for that 10 because 10 is positive, and to be a polynomial, it has to be terms separated by pluses or minuses. So we do have to add some addition signs in there sometimes for those positive values. And that is how you multiply polynomials. So for your practice, you have 8 problems that you can complete. If you would like to do your work on paper instead of on the screen, that's totally fine. If you have the paper copies, that works as well. And then once you've completed all, this should say 8 problems, you can complete your check-in on Schoology.